Case Study: Transforming Vulnerability Management, a case study on AI integration in cybersecurity at Cyberfortress Inc. Artificial intelligence is transforming cybersecurity, especially the field of vulnerability management. Consider the scenario of a fictional company, Cyberfortress Inc., a global enterprise specializing in financial services. The company employs a large team of cybersecurity experts, including data scientists, analysts, and engineers, who are tasked with safeguarding the company's digital assets. Cyberfortress recently decided to deploy AI to enhance its vulnerability management processes. Jane, the Chief Information Security Officer, and Tom, the lead data scientist, spearheaded this initiative. They aim to leverage AI to identify, assess, and mitigate vulnerabilities more efficiently. The first hurdle Jane and Tom faced was acquiring the extensive and diverse datasets required to train the AI models. Cybersecurity data is highly sensitive, and obtaining comprehensive datasets while maintaining privacy is challenging. Jane wondered, how can we ensure the quality and quantity of data necessary to train our AI models effectively? This question highlights a critical issue in AI deployment: the dependence on large, varied datasets to generalize from patterns. To address this, Jane and Tom considered using synthetic data, which can mimic real-world data without compromising privacy. However, synthetic data might not capture all the nuances of actual cyber threats. They also looked into data sharing agreements with other organizations, but faced legal and privacy concerns. To mitigate these issues, they explored federated learning, FLOR, an approach allowing AI models to be trained across decentralized datasets without transferring sensitive data to a central location. This method could enhance data diversity while protecting privacy. Another significant challenge was the interpretability of AI models. Many AI systems, particularly those based on deep learning, are often seen as black boxes. Tom's AI models could flag vulnerabilities, but understanding the decision-making process behind these flags was crucial for the cybersecurity team. Jane asked, how can we make our AI models more transparent and interpretable to ensure trust and accountability? To tackle this, Tom began exploring explainable AI systems, which aim to provide clear, understandable explanations for their decisions. By integrating XAI, the team could gain insights into why the AI flagged certain vulnerabilities, enhancing their ability to take appropriate and informed actions. Despite these advances, AI systems are not immune to adversarial attacks. Malicious actors can manipulate AI model inputs to produce incorrect outputs, such as hiding vulnerabilities or falsely flagging benign components. Jane posed a critical question: what defenses can we implement to protect our AI systems from adversarial attacks? Tom suggested using adversarial training, where AI models are trained on both regular and adversarial examples, making them more robust against such attacks. Additionally, the team established continuous monitoring to detect any anomalies in the AI system's outputs, ensuring that any manipulations could be quickly identified and addressed. Integrating AI into Cyberfortress's existing cybersecurity framework also required significant technical and cultural changes. The established processes and systems needed adjustments, and the team had to embrace a new way of working. Jane was concerned about potential resistance and asked, how can we facilitate the integration of AI into our current systems and culture? To overcome resistance, Jane and Tom focused on change management. They conducted training sessions to familiarize the team with AI tools and their benefits. They also sought feedback and involved key stakeholders in the integration process, fostering a sense of ownership and collaboration. Additionally, they phased the implementation, starting with pilot projects to demonstrate AI's effectiveness before scaling up. Despite these efforts, the dynamic nature of cyber threats posed another challenge. Cyber threats evolve rapidly, and AI models need continuous updates and retraining to stay effective. Tom wondered, how can we ensure our AI models remain up-to-date and effective against emerging threats? The team decided to implement a pipeline for continuous data collection and model retraining. By leveraging tools for automated data retrieval and incorporating real-time threat intelligence feeds, they ensured that their AI models stayed current. This approach also allowed for the quick identification and integration of new patterns and behaviors indicative of emerging threats. Looking to the future, Jane and Tom were excited about the potential of AI to predict and preempt vulnerabilities. Traditional methods often react to threats after they are identified, but AI can enable a proactive approach. Jane asked, how can we harness AI's predictive capabilities to enhance our vulnerability management? Tom developed machine learning algorithms to analyze historical data, identifying configurations or code segments likely to harbor vulnerabilities. By focusing on these areas, the team could address potential issues before they were exploited, significantly improving their overall security posture. Additionally, the integration of AI with other emerging technologies offered new opportunities. For instance, combining AI with blockchain technology could create secure, immutable records of vulnerability assessments and mitigations, ensuring transparency and trust. Jane and Tom explored this integration, considering its potential to reduce tampering risks and enhance stakeholder confidence. The ethical implications of using AI in cybersecurity also required careful consideration. AI systems can perpetuate biases present in training data, leading to unfair outcomes. Jane worried, how can we ensure our AI systems are developed and deployed ethically, avoiding biases and protecting privacy? To address this, the team adopted frameworks for ethical AI development, conducting regular audits to identify and mitigate biases. They also involved diverse stakeholders in the development process, ensuring a range of perspectives and expertise contributed to creating fair and unbiased AI systems. In conclusion, the journey of CyberFortress Inc. illustrates the complexities and opportunities of integrating AI into vulnerability management. By addressing challenges related to data quality, model interpretability, adversarial defenses, and integration, the company could leverage AI's potential while maintaining trust and accountability. Federated learning and explainable AI emerged as promising directions, enabling robust and transparent AI systems. The proactive capabilities of AI, combined with emerging technologies like blockchain, offered exciting prospects for future vulnerability management. Ethical considerations remained paramount, with frameworks and audits ensuring responsible and fair AI deployment. The synergy between AI and cybersecurity at CyberFortress highlighted the transformative potential of AI in safeguarding digital assets and infrastructure.